Welcome to this presentation on SOLIDWORKS MBD. My name is Tandy Banks. So in the SOLIDWORKS portfolio, it's grown quite large over the years, but one of the areas that we're going to focus in today is over in those purple boxes. That's where the technical communication area is. And so MBD is one of the products within that portfolio. And so let's understand a little bit more what is SOLIDWORKS MBD. Well, it's a tool that's going to allow us to define, organize, and publish 3D PMI. I'll cover PMI in just a little bit later, but what that really means to us is that we're going to streamline production, we're going to cut cycle times, reducing errors, and it's going to help us comply with standards. So when we look at products that we want to produce, something like this bushing that we've got here on the screen, big silver donut, as a mechanical designer, mechanical engineers, we take these multiple featured products and we start breaking them down. SOLIDWORKS is a great tool for us to be able to do that. So as a SOLIDWORKS designer, one of the first things I do in the process is I create that solid model. But as I'm creating the model, I'm using features to define the individual manufacturing practices that we're going to need to use in order to create this geometry. So we might start off with saw cutting a piece of aluminum bar stock, and then we want to face that off, get a good true side on that, and then we were able to take that to a lathe and start turning down the ODs and IDs. We'll finish that up with some milling and drilling processes in order to create our geometry. And so, that's the steps in the physical world in order to create that model. And we know that we want to end up with a true 3D product at the end. And so we start off with 3D modeling on the front side. But the problem is today, we're still communicating a vast majority of our designs using a 2D geometry. And so what that ends up giving us is a translation of the idea that what we have in our heads of a 3D design, what we produce in SOLIDWORKS as 3D geometry, but then we have to use this 2D translation method in order to turn around and produce a 3D part on the end. And so there's a lot lost in that translation. And over the years, we've adopted standards and practices where we show these 2D orthographic drawing views using things like dimensions, tolerancing, geometric tolerancing, in order to define our design intent. So what's the problem with that? Well, it's time consuming and it's costly. So one of the things that's pushing this round of MBD, model-based definition, in our environment is MIL standard 31000A is a standard that the DoD put together a committee. They looked at the ways that we were doing things today, and they found that we were grossly wasteful in this process. And so up to even a half of your design team's time is spent making and maintaining 2D drawings. That's half. So somewhere between a third and a half of the time is spent doing that. So what's the new process, or what's the possibilities that we have available to us? Well, MBD, like the screenshot I'm showing here on the screen now, gives us the ability to do this all in a 3D environment, and we're able to save a very good portion of that translation between 3D to 2D back to 3D. So we'll get into the software in just a little bit, but I want to dig a little bit deeper into what is MBD. Well, as a philosophy, as a method, MBD, model-based definition, is the practice of using 3D models and to grab product manufacturing information and any of the associated metadata with that. So what's PMI? Let's dig a little bit deeper into that. Product and manufacturing information. These are things that we put on traditional 2D drawings today, but that we're also capturing in our 3D models. Things like dimensions, tolerances, weld symbols, tables, coordinate systems, notes, specification, all those things that we're grabbing not only in traditional 2D drawings, but also capturing as metadata within our 3D models. So the SOLIDWORKS MBD, why did you take time out of your day to sit and listen to me talk about MBD? Well, again, I mentioned that a lot of design teams, and even in my own design experience, I worked for some very large manufacturers where I used MBD methodologies. And the reason why we did that is because we saw that our design teams were spending somewhere between 40 to 50% of the design team's time just maintaining those drawings, where we already had the information captured in 3D models. And this, again, DoD, the committee that they put together, saw that not only in their own processes, but that of their vendors. We actually can create less documents using the MBD methods. Now, I know a lot of people say, well, producing a PDF of a 3D model, isn't that the same of making a drawing of a 3D model? Well, you'll see in a little bit whenever I get into the software that we actually can reduce the amount of pages, drawing views that are needed in order to fully convey our design intent. And so we can result in less documents to manage. I mentioned that the translation of 3D to 2D to 3D. That's one of the main things that we're trying to remove is that translation, because it's very costly. Even though, you know, I had classes in college and spent many years over the last 20 years teaching people how to read technical prints, it's still, you know, not the easiest thing. And we find a lot of folks in the manufacturing realm have a hard time with it, and they'll, you know, they'll not properly produce the parts that we need based off of those 2D drawings. We're getting more and more portable. You know, being able to have things like our smartphones and our tablets, the cost of tablets and proliferation of that, those hardware models throughout manufacturing organizations allow us to be able to carry our drawings and our information with us much easier today. And we can get even leaner when we use 3D models in MBD. And all that's going to result in the possible cost savings because we're more efficient, and we reduce errors because it's easier to understand the design intent. SOLIDWORKS MBD is a little bit unique in that we have 3 different delivery methods. We have the actual SOLIDWORKS model where we capture that design intent and produce our designs. We have a 3D PDF that's template driven. It's a little bit different than what we've had in the past, and this is what allows us to comply with MIL standard 31000A. And then we have our viewer, our e-drawings package that's allowed us to convey that design intent throughout our organizations over the last decade plus. And so those are the 3 different delivery methods that we have to work in within MBD. So with that, I'm going to get out of the PowerPoint. Let's take a look at what this looks like out in the real life. I'm going to talk about this a little bit backwards today. I'm going to look at the end product, and then we're going to look and see how we got there. So this is Adobe Acrobat, and this is the free viewer. This is what's used on 98% plus of the machines out there in the world, where we have a free Adobe Acrobat viewer, and we're able to read this, this dynamic 3D PDF. And what I mean by dynamic is whenever I hover over into this graphics area, I'm able to pan, zoom, and rotate. I can switch between different captured views. And if you'll notice, this is all laid out into a template, so I can control things like the metadata, the part numbers, the weight, description, revisions. And I can still go through the practice of showing specific areas of my design, tailoring that to the audience, and being able to show them, you know, again, the design intent or the manufacturing method that I want to work with. We work with assemblies as well as drawings. We can have multi-sheet PDFs. And so here you can see I can pan, zoom, and rotate. I can select a component, and it will interactively work with bill of material to highlight that component down in the table. If we take a look at some other examples, get a simple gear assembly here where we can again pan, zoom, and rotate. We can show things with section views, removing geometry as needed, showing dimensions even for assemblies, and again having those tables. MBD kind of got its life in the part definition, and that's really, you know, from a purist standpoint, that's really where the majority of the information is at the part level. And so if we look at a 3D PDF of a part, again being able to pan, zoom, and rotate, we can highlight dimensions. We can have additional information like note blocks. Got some of those orthographic projections that we can show. And we can even show multiple configurations. So for something like where we've got a different version of a component, we can show those as well. One last example, and then I'm going to show you how we build these from scratch. This is the example that I'm going to build for you today. And so I wanted you to look at it in more of a completed state, and that way you understand the steps in the process and how I'm going to work towards those. SOLIDWORKS MBD gives us the ability to drive, you know, the views of exactly what we want our users to see, but at any point in time, the user can rotate out of plane, making it a little easier for them to understand where those dimensions are being attached. And so that's where we're able to convey our design intent using less sheets. Something that I would maybe have to use 20 to 30 sheets in order to convey a very complex design. I'm able to give a couple of 3D views that are dynamic, and so that way the production personnel or vendors are able to understand that information very easily from these 3D PDFs. So I'll kind of stop there for the moment, and let's move on into SOLIDWORKS and start capturing some of the PMI and producing our 3D PDF. I mentioned that we've got different delivery methods. I wanted to go ahead and show one of these completed documents here in SOLIDWORKS as well. So within the SOLIDWORKS environment, MBD gives us a Command Manager tab at the top, and it also gives us this Captured 3D Views area at the bottom. Much like the film strip I just showed you in the 3D PDF, we have the ability to switch between different views. So we can convey all this design intent for anybody in the organization that has access to a SOLIDWORKS license. We're utilizing DimExpert dimensions as well as feature dimensions and any other annotations that we want to specify. Whenever I switch to that last view, it switched configurations because these capture views are much more than what we've had traditionally as name views. We're able to capture not only the camera angle, but also the display state of the annotations, the display states of the models, and then we're able to switch back and forth between those very quickly and easily. So let's build one of these from scratch. This is that component I showed you just a moment ago, and I want to start off with the process of using DimExpert in order to be able to capture our design intent or our PMI. And so I'm going to use one of our automatic dimensioning schemes today. And all I need to do is set up whether this is a prismatic or turned part, the plus or minus or geometric tolerances, and then I need to specify some datums. So for me today, I'm going to select on this face, right mouse button to accept that. I'll do that 3 times for the 3 different datums that I need to use. And now I have my primary, secondary, and tertiary datums defined. A simple green check mark is going to go through, and DimExpert is going to fully define the geometry of this component using PMI. So whenever I show this to folks, they want to know, where do these tolerances come from? Because that looked a little bit like magic. And it is. It's a little bit like magic. But for many years, SOLIDWORKS has used our templates to define where that information comes from. So for within the SOLIDWORKS options, under Document Properties, we have the DimExpert column. And within this chapter or this area, we can specify what we want to have to be our lengths, whether we want size dimension tolerances. You can see here plus or minus 1/4 millimeter. We can set up what our different decimal place values are for those, location dimensions, chain dimensions, whether we want to use chain or baseline, geometric tolerancing, chamfer, and display controls. So these are things that have been in the SOLIDWORKS software and in the document properties for many years, even though we've only had MBD for a little over a year now. And so you might visit with your CAD admin or your standards librarian and see what you have in your document templates to be able to set these different controls. But I wanted to point that out to you so you can see that that's where these values for these dimensions and these geometric tolerances, where they were established. One of the neat things that we have in DimExpert is we have Show Tolerance Status. This is a functionality that's both here in the MBD toolbar as well as over here on the left-hand side in our Feature Manager area. And what this does is it color codes all the features or faces of the model, letting us know of their definition. All the faces that are in green are fully defined. Any faces that would have been in yellow or in gray would have been underdefined. So now that I know I've got my PMI captured here, my product manufacturing information, I want to start the process of capturing our 3D views. And so I'm going to open up the 3D views area down here in the lower area of my SOLIDWORKS software. And I'm going to start with more of a pictorial view. It doesn't have to be exactly isometric, but I kind of specify some type of pictorial view, and then I want to choose to capture that as a 3D view. As I mentioned earlier, this is different than named view in SOLIDWORKS that we've had for years. This gives us the ability to capture configurations, display states, annotation views as well as the camera angle that we're looking at. I'm going to give this a name of ISO today, ISO, just to give us a general pictorial view. And I want to use all the annotation views and the default configuration and display states. A green check mark will lock that one in. And then I'm going to go through the process. I'm using hotkeys today of Control 1 to get to a front view. And then I want to capture another 3D view. This time I'm going to call this one front. And I only want to get the front annotation view. I don't want the annotations from the right, top, or notes area to be displayed. Green check mark. I'll switch that using Control 4 to a right view. Capture view for right. Likewise, I only want to get the right annotation view. And I'll finish this off by capturing a top view. Control 5. You certainly could use the orientation and the display bars in order to get there, but I do like using the old hotkeys. And so now what I'm able to do is I'm able to quickly switch between those 3D views by double clicking on the thumbnail down here below. And I can cycle through to see how I'm going to convey our design intent. Now, if I chose to use the delivery method of SOLIDWORKS, I'd just simply save the SOLIDWORKS document, and all this information would be captured and available for viewing for other users. But today I want to focus a little bit in the 3D PDF. That is the most popular delivery method, and it's what most of our customers are thinking about when they're talking about MBD. And so you can see that we've got two areas to interact up on the Command Manager toolbar. We have a Publish 3D PDF. We also have the Publish eDrawings. And then down here below we have a small icon for Publish to 3D PDF and Publish eDrawing. Whenever we choose to publish our 3D PDF, we're going to choose a template. I'll show you a little bit more about the templates in just a moment. But we're able to select from default out of the box of eight different templates from SOLIDWORKS. You can see 4 in part, 4 in assembly, and then I have a couple of GoEngineer templates that I've created. I'm going to use my GoEngineer part template. You'll see within the template we're setting up things like the main view, the title block area, and the location of the thumbnails. Now I get to choose which of my views, including primary views, that I want to be captured in my little thumbnail strip down below. I'm going to select the ISO through the top views that I just created. And now I want to switch over and go to the next button right here in my definition window. What this is going to allow me to do is it's going to allow me to do things like editing title block information. Let's say that I wanted the part number to be mapped to the number metadata property in my file. Likewise, I want the SOLIDWORKS material to be set to the material property. In the comments and designer area, I can come in and I can specify things like my name or initials. And this information will be used when I click on the green check mark, and they'll be published into my 3D PDF. We'll call this GoEWebinar today. Put that up on the desktop, and it goes through the process. We'll see a little flash and dash happening as it's going through, and it's capturing that PMI, and it's exporting that out into our 3D PDF. So let me pull up that 3D PDF that we just created. So double click there and we bring up our GoEWebinar toolbar. You can see today's date's been established, the material designed by, and the part number. So a little bit more here in the Adobe Acrobat. This toolbar here is provided by Adobe and allows us to be able to do things like see the model tree, and we can even dig down and see the 3D PMI information as it was captured and translated over into the Adobe PDF. This is where we're also able to attach a step or parasolid version of this file in order to be able to comply with standards that require that the actual model geometry be available in this 3D PDF as well. You can see the film strip below, wherein I have these dynamic views. You can pan, zoom, and rotate. It's the front view I created earlier, right, and top. We also have areas where the users can key in note values. And these can be saved even using the free Adobe Acrobat Reader. Things like these notes can be saved in by the user. So that was the process of creating, very, very easy in order to be able to capture the 3D views and create the 3D PDF. I'll minimize that, and I want to come back over here for a moment and take a look at the template editor. The template editor provided by the SOLIDWORKS MBD tool allows us to be able to use things like a background image, whereas I've specified these orange boxes and a couple of GoEngineer logos. We're able to size and place where we want our primary view to be. We can add in notes areas, things like those placeholders for part number, which can be assigned to a SOLIDWORKS custom property. Or we can have those be just dynamic notes or bill material areas as well. So you can see the user interface and the tools in order to create these templates are very easy to work with. We can create independent viewports, projected viewports. We have our primary viewport, which is required, as well as our thumbnail film strip down here at the below that was required. But we can decide where we want that placed and the size of those. I mentioned the background is just a simple image. So you can have those as JPEG, PNGs, TIFF files, bitmaps. You can use SOLIDWORKS to create those, or your favorite graphics software. I even use the shareware Inkscape in order to create these that I'm using here today. We've always got our SOLIDWORKS help, so if you need more information that I've given, it's just a button click away. Further details about how we can get deeper into our MBD template editor. So I'm taking a look at our time. I've gone in about 22 minutes here. I want to switch back and finish up a couple of things, and then we will wrap this up with some questions. So I mentioned the 3 delivery methods. I showed you 2 of those using the SOLIDWORKS model as well as a 3D PDF. Again, that's a template-driven 3D PDF, and that helps us comply with MIL Standard 31000A. And then we also have our eDrawings viewer. To wrap up this presentation today, I just wanted to recover this slide. One of the main things that we're trying to do is we're trying to reduce the effort in order to convey all that design and manufacturing information, what we call PMI. We're trying to, reduce that up to, 40 or 50% of what we're currently doing. We're trying to create less documents, and we do that by having those dynamic views as opposed to the orthographic projection, which also helps us when we're eliminating that 3D to 2D back to 3D translation. We're giving more delivery methods, being able to use things like smartphones and tablets, and all of that ultimately will allow us to be able to reduce the errors, increase our efficiency, and give us cost savings to the bottom line. Yeah, my name is Tandy Banks with GoEngineer, and I hope you enjoy this presentation of SOLIDWORKS MBD.